Alright, here we have another one that says find the center HK and the radius R of each circle. Graph the circle and then find the intercepts if there are any of the graphs or of the graph. Okay, so looking at our problem here, this really doesn't look like anything that we've done before. Everything that we've been looking at has either been in standard form or was easy to put in standard form, but this one is much different. This is why we learned to complete the square in previous math classes, so we could use it here whenever, especially whenever it comes to these conic sections. So just to remind you about how to complete the square, we're going to have to rewrite this. So we put our x's together, and then we leave a space, and then we're going to put our y's together, and then we're going to leave a space, and we're going to move our constant term over to the other side. So by adding 46 to both sides, we'd have 46 on the right. Now remember, our goal in completing the square is to create a perfect square trinomial. And we do that by always doing the same procedure. We take 1/2 of the middle term. So 1/2 of 6, which would be 3, and then we square it. So that would be 9. That is what we're adding in to make this a perfect square trinomial. Now if you add something to the left-hand side, don't forget you have to balance it out by adding it to the right. Then we're going to do the same thing with the y's. We're going to complete the square. So we're going to take 1/2 of the middle term, which would make that a -3, and then we would square that also, which makes that a 9. So we'd have to add 9 to complete this square, make it a perfect square trinomial, and we'd have to add another 9 to the other side to balance. Alright, by us doing half the middle term and then squaring, we've created that perfect square trinomial, which if you are not sure about that, what I'm talking about is if we were to factor this down, then this will factor into something times itself. That's what a perfect square is. In fact, this is going to factor into x plus 3 quantity squared. It will always factor into the variable and then that halved amount, half of that middle term. So here we'd have plus, again we created a perfect square trinomial, so it will always factor into the variable and then that half of that middle term, which in this case is y minus 3. So if you get the technique down, it always works this way. Equals, and here we have 46 plus 9, which would be 64. Now this is our standard form of the equation, and from that we can now figure out what is our center and what is the radius. Remember, your center is that h and k value. So x minus h means that h has to be a -3, and y minus k means that k has to be a 3. Have you noticed that these are always the opposite signs? That's very interesting, isn't it? Now for our radius. Our radius squared in that position is a 64. So if we take the square root of both sides, we get the radius equals 8. So we'll finish this up in the next one.